Hello, today we're here to talk about security and BYO-PC. In other words, enabling an employee or a contractor to be able to bring their x86 devices into the organization. And if you're going to do that, there's two golden rules that Moka5 has in place. So number one is you're going to manage a container, not the device. So device management is an old world metaphor. It worked well when we understood there were only a few devices, but now we have this massive device proliferation. There's just way too much. It's kind of crazy. You've got the right to bear arms and the right to arm bears. You can do whatever you like. However, nowadays, what you can do is you can create a container and deploy it on a device, manage that instead. The second thing that we want to do is, because that device is unmanaged, you never, ever, ever allow it onto your corporate network. So from provisioning through to daily work through to killing, you don't let it onto your network. So that's really the model for Moka5. The first thing we talked about though is containers. What do they look like? So let's talk about containerization in the Moka5 world. So containerization, we're taking your apps and data and putting them together, deploying them with a set of security policies and deploying them out to a number of different endpoints. So those endpoints, they're obviously radically different devices, and the containers that exist on them look different. On x86, it's a full-blown virtualization stack with OS app and data, and on the other devices, it's much more data-oriented. So they're data access-oriented, and we give you a more data access-oriented container. And of course, we don't just deploy them, we also continue to manage them. So you can update the container, you can change security policies around them, and of course, you're also able to end-of-life them. So that's what we mean by containerization. I think to explain further, maybe if we just get a practical use case, then we can start to see the light a bit more. Let's look at that now. Okay, so let's look at a use case. The CIO, he's looking at his spreadsheet and he's like, whoa, if only I could save some money. I would be the hero of the hour. So he sees that you've got maybe 60,000 contractors and they're going through a hardware refresh this year. They all have a piece of corporate laptop so that they can do their work. All right, lovely. So $60,000, $1,000 a pop, that's $60 million I'm going to be spending on these machines. And I look at this Moka5 stuff and say, hey, these guys, they're going to have no back-end infrastructure. It's not like traditional VDI. I'm not executing stuff in the data center. They're going to deploy containers to their devices. So I don't spend there and I don't spend there. And I save tens of millions of dollars. This is pretty cool. Let's make it happen. So from a security point of view, you've got to be comfortable with how this model works. You're probably thinking as a CISO, my word, I'm going to end up with a whole bunch of machines that are going to be coming in onto my environment. How can this possibly be secure? All right, so let's talk through it. So the first thing is, when I bring a laptop in, it's only ever on the guest Wi-Fi or perhaps VLAN back out to the internet. Our maxim, remember? No unmanaged devices on the network. There is, however, a container on that device, and it's a full-blown virtualization OS. And within that, you can have a VPN client, which connects in the same way that you're used to managing for years or decades, just the same way as a laptop. So now you have someone who's able to do all their work over a secure platform in a secure pipe into the organization, even though the host is on the internet. So you are never exposing your corporate network. You have a managed container, an unmanaged device, and you're not allowing that perimeter to be breached. Let's look at it in a little bit more detail. Let's see. Okay, so let's have a first look at the technology in practice. First of all, provisioning. So if these guys are going to be able to get up and running, they need to be able to get up and running off network. So we've made this a flow which is real easy. So here you can see that the user's going, they've been sent a link and their username and password. You can use two-factor auth as well. And what they're doing is they're going and putting in their username and password. They get a simple button and then it talks them through how to provision. The container downloads. They hit play, they're off to the races. Very, very simple. Okay, so I've now got my container on this device, and you're saying that you don't need to manage it, but can I really trust it? What if I've got malware that gets down on the device and that malware executes, and maybe it's a keylogger or a screen scraper? Well, we at Moka5 have thought about that, so we've built antivirus into the Moka5 player itself. So that's basically going to scan the host for any errant processes that are in memory, and it does that at container start or during container execution. And if we find something that matches a known bad signature, we stop the execution of the container. So in that way, you're able to ensure that you're not managing the host, but the host is in a good enough situation to be able to run your corporate environment. Pretty good, huh? If you decide that you have other requirements that you need to enforce on that host device, we have something called the host script mechanism. What this host script mechanism enables you to do is to take a script, write it so that it can be deployed to any device, and we will execute it before we start the player. So what this means is you can ensure that there are certain levels of patching, certain levels of, if you want your own AV, if you want your own firewall, that those are present on the device before launch. So we give you, the admin, the flexibility to make sure that the devices are good before it runs. Okay, so we've got a container on the device, but what happens if someone wants to come along with a can opener and open the container? We thought about that. What we do is we encrypt the containers with AES-256, which is an industry standard, to make sure that no one can get into them. On the x86 platform, because we're using virtualization, it means there's implicit separation between the host and the guest environment. There is the same piece of hardware underneath, but essentially there's two OSs running side by side, which means that many of the problems that you might have with other forms of containerization don't exist. So we've talked about policy management. Let's talk about a couple of those policies. So a very obvious one is, obviously, if you're working on a host environment, there may be an exchange of information, say drag or drop or copy and paste. That can all be managed by you, the admin. You can switch this on, switch this off. You can do whatever you like. Likewise, say for example, do you want USBs that are plugged into the host to be accessible from within the guest? We allow you to control that. And we don't just enable you to control it for the entire estate. We enable you to control it on a group by group basis. Our management console ties into Active Directory, so you can just piggyback off your groups. If you have developers, you want them to be able to use USB devices, you can, but everybody else locked down. One last thing, of course, is printers. So being able to print information, that can be a potential egress point, so we protect against that also. We've got too many security policies to talk about here, but we have a rich policy set of over 100, so it's well worth having a look at. So forensic analysis is a key piece of security. You have a flow today. That flow involves getting the laptop back, being able to do forensic analysis over the drive, perhaps using a tool like Encase to look for any crumbs which might exist to errant user activity. You can do something very similar with the Moka5 container. We've worked with many companies on their forensics flow, and they're very happy with the result. And the final piece of the puzzle, of course, has to be end of life. So if I want to be able to end of life my container, someone's left the organization, or perhaps they're even up to some nefarious activity, I can either revoke, which will prevent access but leave the container present, or kill, which will remove the container altogether. We all know that AES-256 is great, but given enough time and energy, anybody can crack anything. So you have the ability to do that from the management console, as is shown here. You also have the ability to set time bombs for both of those actions, so that if the user's smart enough to turn off the network, they'll automatically be revoked and then subsequently killed. Thank you for taking the time to listen to us today. We believe that Moka5 and security work really well together. Often security is referred to as the Department of No, and we feel that what we can do is work with you to turn you into the Department of Yes when it comes to BYO, and because that's the desktop, it affects many people, and it will make you dazzlingly popular. So give us a close look, please. We'd love to talk to you.